Welcome to The Explainer. Today, we're diving into the future of a technology that's completely changing the game for AI, Retrieval Augmented Generation, or as everyone calls it, RAG. We're going to see how it's going from just a simple add-on to becoming the very core of how AI is starting to understand our world. So here's what we've got on tap. First, we'll get into what RAG actually is and why the best way to think about it is an open book exam for AI. Then, we'll look at the incredible breakthroughs that are giving this AI what you could almost call a brain. After that, we'll check out how engineers are making it faster, cheaper, and way smarter, before finally seeing how this amazing tech is being built to be used safely out in the real world. All right, so let's jump right in. What is RAG exactly? Okay, stick with this open book exam idea. Before a chatbot gives you an answer, RAG lets it go and look up the actual facts from a private library of documents. So let's say you ask your company's AI assistant for the latest sales figures. Instead of just, guessing, RAG lets it pull the numbers straight from the official quarterly report. This keeps its answers grounded in reality, which makes it so much more reliable. But, the first version of RAG had this massive problem. See, it would just do a quick search, grab a handful of documents it thought were relevant, that's the top K part, and basically just cross its fingers and hope the answer was in there. This whole top K and praying thing, it just wasn't reliable for any question that was even a little bit complicated. So that whole hope for the best strategy, that wasn't going to cut it. It became super clear that AI needed to understand the bigger picture, the context, and the connections between things. It needed to see the whole forest, not just a couple of random trees. I mean, think about it. The real world isn't some neat little list of facts, right? It's this messy, complex web of relationships. An email about a project delay over here is directly connected to a specific budget line in a financial report over there. So the big question became, how on earth can an AI learn to navigate that web? And what's so cool about this slide is it shows exactly how the solution evolved. We started with what's called local RAG, which is basically like asking a librarian to find one specific fact in one book. Then we got graph RAG, which is more like a detective, connecting clues across a ton of different documents to find hidden patterns, perfect for stuff like spotting financial fraud. And now we have global RAG. This one's like a market analyst who can read the entire library at once to spot huge trends and answer big picture questions like, what were our most successful products last year? But here's the thought. What if the AI could do more than just find information? What if it could actually think about it? Well, that's the wild idea behind the next massive step up called Agentic RAG. This is Agentic RAG, and it is a game changer. Instead of just search, then answer, this creates a system where the AI can plan out its research, reflect on what it's finding, and, get this, even correct itself if it goes down the wrong path. It's less like a librarian and way more like a whole team of research assistants debating a topic and weighing the evidence to find the real truth. And that is what you need for messy, real-world problems. And this is where things get really wild. A recent study found that for really complex research, a super old keyword search algorithm from decades ago called BM25 actually smoked the modern advanced AI retrievers. It beat them by almost 30%. How is that even possible? Well, it turns out it's because these new AI agents are just incredible at one thing, breaking down a big, fuzzy question like, is this a good investment, into a bunch of super specific, keyword-heavy little questions. And when your search is that precise, good old-fashioned word matching is often way more effective than a fancy system trying to guess a vague, semantic meaning. So to handle all this messy info from the real world, some of the most advanced systems now use a multi-agent debate. You've got different AI agents that all review the evidence, they literally argue with each other about whether it's legit, and then a final aggregator AI synthesizes only the facts that they all agree on. It's an internal fact-checking machine, and it's been shown to boost accuracy by over 11%. Okay, so these systems are insanely powerful, but all that power costs a lot, both in speed and in money. All that thinking and debating takes a ton of time and energy. So how do we make this stuff practical enough to use every day? So the core issue here is what engineers call an architectural mismatch. The part of the AI that finds information, the retriever, works with compressed math, which is super fast. But the part that writes the answer, the generator, needs the raw, uncompressed text. It's like having a librarian who uses a lightning-fast digital index to find a book, but then has to read the entire thing out loud, word for word. It creates this massive bottleneck. But Apple came up with a breakthrough called CLAR that completely solves this. It basically creates a shared language so that both parts of the AI can work directly with the compressed info. It's like teaching the AI how to read a zipped file without ever having to go through the slow process of unzipping it first. This is a huge time saver. And the result of this? It's just incredible efficiency. Clara can compress the data the AI needs to look at by up to 32 times. That drastically slashes the processing demands, all while keeping the answers just as accurate, and in some cases even more so. And when you start combining this with other smart tricks like intelligent caching, you can get a mind-blowing 73% reduction in cost and energy use. Now that is what makes this kind of advanced AI practical. It's what could bring it to your phone or laptop, not just keep it locked away in giant data centers. So now that we have AI that's not just smart, but also super efficient, it's ready for its next great leap, understanding our documents the way we do, as a mix of words, images, charts, and data. And this is where we get multimodal RAG. For the very first time, we have AI that can understand not just the words in a report, but also the charts, the diagrams, and the images that give those words their real meaning. It can finally see the connection between a paragraph talking about a sales dip and the actual downward trend in the graph right next to it. And this just unlocks so much value. For public policy, an analyst could ask the AI to summarize trends from a report just by having it read the charts. For engineering, an architect could look at a blueprint and ask, hey, what material is specified for these support beams? And get an instant answer pulled right from the diagram itself. Okay, so last but not least, to actually use this powerful technology safely and effectively in the real world, we need the right tools and infrastructure. We need the essential scaffolding to build enterprise AI on. We're moving way beyond simple accuracy scores now. The new standard focuses on a triad of really important questions. First, context precision, which asks, did we find the right needle in the haystack? Then, context recall, which asks, okay, but did we find all of the needles? And then, maybe the most important one, faithfulness, which asks, is the AI's final answer based only on the needles it found, or did it start making stuff up? That last one is absolutely critical for building any kind of trust in these systems. And this is all held up by a whole ecosystem of tools. You've got advanced evaluation platforms that act like quality control. You have high-performance vector databases, which are basically these hyper-efficient libraries for an AI's memory. And you have smart AI gateways that are like traffic cups, sending the easy questions to cheap, fast models, and the really tough questions to the heavy hitters. It's all about managing performance and cost. So what started as a simple fact-checker has evolved into this incredibly sophisticated reasoning engine, one that's on the verge of understanding the entire breadth of our knowledge, text, images, and data all combined. Which really brings us to a final, pretty big question. Now that we're actually building it, what's the first problem we should ask it to solve?